Well, hi guys and girls, Emma again. Welcome back to the spare room and welcome back to this little traction engine build on Patreon. Next part really, because I've been slack with this, is to make safety valves. I'm not going to take this apart because it's all been set and it's a good valve. It's set to about 30 psi and I really don't want to set it again. And this is the valve out of my stationary engine to the same design, so that works in that, and it works nice in this. And that's what we want to end up with, is another one of these. Now, the one that's drawn in the book is like this, and all that is a hole through and a countersink for a screw and a nut on the bottom. Don't like this much for a couple of reasons. First and foremost, this hole in here, if we pull it apart and have a look, see, it's just got a countersunk screw in there. This hole's more or less the same size as the screw, with the lapped in valve with a screwdriver. For one, it's almost impossible to get to seal. For two, when this blows, you've only got this little bit of thread space in here to let the steam go. So what happens is, when you release a big quantity of steam in a boiler, is that the steam expands very quickly, like instantaneously, and this has to have somewhere to go. This valve doesn't really provide that, and it gets away with it because usually they're all pretty drippy and leaky, and that works. The other problem with this valve that I don't like very much, and I really have a bit of an issue with, is that the nut's inside. The nut's got to be small enough to go through this hole so that you can take it in and out. Now, you only have to fiddle with that a little bit to try and make it adjust, and this nut drops off the bottom and this shoots out past your ear and you've burnt yourself. So there are reasons why this isn't a particularly good valve. This valve here is based on Titch as LBSC locomotive, little 040 tank, tiny 040 tank. It's got a proper ball, and that sits on a seat in the hole that diameter. So when the ball lifts, you've got at least that diameter escaping out here. So steam can dissipate pretty quickly out of a valve like this. It also is shut or open, so it doesn't dribble and it doesn't flutter, anything like that. When it gets up to speed, it's open, and it's fully open. And when the steam drops back to pressure, well, it's fully closed. So that's a pretty good valve. There's not much to it. And this is a much smaller version of the same valve. I can show you what's inside here. There's a ball that sits on a seat in the bottom there. That's very simple, and it's got a pin. It's got a conical hole in the bottom to cover the ball, and that's just there's plenty of room around that. And that pin has a spring on it, and then there's a hole in this top nut, and this is a sliding fit in there, and we screw all that together. We can pull that out to release the valve. And the spring pressure holds the ball on the seat. When it pops, the steam can go right through with a hole that diameter, right through, no obstruction, no nothing. Very safe little valve, and very easy to make. This one's tiny, and that's for another project. There will be some documentation about that on YouTube, I think, keep your eyes out for that. So the safety valve drawings are in this book. That's Titch. It's a nice book to have because it shows in some detail most locomotive and steam fittings and how to make them. But this is the little valve here. We've modified it a little bit, but it's quite simple. It's just got a thread, it's got a seat, and it's got a screw-in nut and a plunger on top, and a ball that's 3/16. So we're going to need some brass. We're going to need a piece of stainless steel, it's probably best to make the plunger. And we're going to need some ball bearings. A couple of them, one to seat it and one to use in the valve. They're pretty easy to get. If you go to the cycle shop and get stainless steel ball bearings, these cost me like $5. There's 3 or 4 different sizes there. They're 1/8, 5/32 and 3/16 there, I think. So go and get yourself some of these. And let's get in and make a valve. It's a piece of stock that's already cut. We're going to chuck him in the lathe and drill him right through. Then drill it down tapping size for this on here, which I believe is probably, I think I threaded this 5/16/32, which is nice fine thread. So we're drilling for that size there, and cross drilling. I've actually put 3 holes in this one. It's probably not a bad idea, but you could just cross drill both ways. And then finish him off with a slot drill, a little slot drill. Probably 1/4 inch. And ream this hole so you've got a nice square seat. Then we're going to turn him around and put this thread on it. And that'll be the body finished. So let's do that. So basically I've just faced the end of the piece of bar and machined it down so that it's going to have enough hexagon on there to put a spanner on, or a wrench, and still be enough to put a thread on it. I've made it just the same as this one, but that looks to be about 15 millimeters. And next job is to put a center drill in it, or a spot drill. And we're going to ream this through 5/32 to finish it, so probably a little bit under that would be a good size to drill it. We're going to tap this 5/16/32, and tapping drill for that is 7.3. The drawing says that wants to be about 11/16 deep, but it doesn't want to come out through the bottom, I guess, so I'm going to drill that about 16 millimeters from the point. And I've just cleaned the bottom of the hole out with a 1/4 inch slot drill. Make sure we've got a nice nice square corner there. And next job is to run a 532 reamer through. Same one that we used for the crankshaft. We haven't got a reamer, a nice new drill will do the job and give you a good square corner as well. But make sure you're only taking about 10 thou out of the hole, sort of 5-10 thou out of the hole to clean it up, and then you'll get reasonable results there. Next job here is to thread this down. It doesn't matter really how far, but 5 or 6 threads we probably want. A little bit of a burr there, so I'm just going to take that off. And that's that part of that operation pretty much done. The next job is to have a look. We've got a nice square shoulder down there to sit the ball on. Make sure at this point that the 3/16 ball doesn't fall right through and that it's got clearance all around it, which is what it needs. Because we're only taking the point off the drill with the end mill or with the slot drill, it's not cutting in the center, so an end mill will do the job, but just take it really gently. A slot drill is probably better. Because we're only taking that piece out there, the curve of the ball gives us plenty of clearance there to use a 6mm end mill in a 7.3mm hole. So on a 3/16 ball, there's plenty of room there. So that's what I've done. Next job's to drill 3 holes around it. You can cross drill it this way and this drill way, but probably easiest, because we've already got a piece of hexagon stock, is just to hold it in the vise and to drill the 3 points. Now this won't take you long to do, because this is already a hexagon. You just mark a line from the end and center punch them in the center of the hexagon flat, and hold it in something pretty solid and rigid. I just used a little Stanley toolmaker's vise. Clamped it in there and drilled it in 3 places. Very, very simple job. Because there's 3 holes, the other 2 are always out of sight, so you can't really see whether they line up or not properly. So that's heaps good enough. Next job is to chuck it back in here and machine this end down to 8mm to match the thread for the boiler or whatever you used, and thread that. And that's the body pretty well complete. So I've just followed that along, the thread along nicely with the tailstock quill. It's a fairly coarse thread and it's fairly easy to get it cross-threaded, so just be careful of that, but don't be afraid to get in and make another one straight away. Don't leave it until another day if you muck one up. The same goes for any parts really. If you get in and make one right now, the second one's always better. If you leave it till next time, it never gets done. keep a knife file just to undercut the back of the thread there. That does two things. One, it means that the thread's going to screw all the way up through your bush, and secondly, it's going to give you some sort of a captive place to hold a fibre washer or a copper washer to seal it, especially as this fitting's coming in and out all the time. So that's the safety valve base made. So the next part of the valve's a little nut, and that's threaded outside 5/16/32 to match the screw, to match the hole we tapped. And it's drilled up the centre. A 3/32 or 2.4 millimeters. It doesn't matter much what it is. I'm aiming for something about that size, because we're going to make the other part to fit it, and that's heaps good. Don't rush out and buy a new reamer or a new drill bit or whatever you need. You may not need it again, and if you've got a couple of precious hours in the workshop, then it's much more important to get something finished or complete than it is to go shopping and come home and have dinner and go to bed. By all means, order one for next time if you discover you need one or you haven't got one, but I've just drilled that number 43, which is pretty close to 332, and tap the outside of it 5/16 by 32. There's quite a taper on these button dies, so I'm going a little bit further than I need to. And this wants the sharp edge taken off there nicely. Next job is to put a screwdriver slot in it, in the top here. And I'm going to do that before I part it off. The same deal, I'm just going to use a little knife file. A hacksaw will do a nice job if you're careful. You can make a jig to do it, you can do it with a slitting saw. I'm just going to put this in the vise and cut a hole in it with a file. And that's, if we focus that, it's a couple of minutes work, not a big job. Next job's to part it off. The book says 3/16 long. But just make sure that the thread goes all the way through. Just going to give that a clean up on the back. And put him upside down in the safety valve and take that little pip off with a file. You can't see that face. It wants to be flat and nice. And we can make a proper holder for this and face it again in the lathe. Or we could set it up in a collet and face the back of it that way. Is probably a very easy way to do it if you've got a collet that it fits. but not a big job to fix. Next part's the little guide rod to hold the ball in place. It needs to have a stem on it that's 332 or 2.4, whatever you used, millimeters to slide inside that nut, and it needs to be long enough to fit a spring in there and still poke out the end, but it doesn't want to be too long or you're going to end up with a broken piece when you try to machine it. I'm going to do this in a collet, but sit the ball down inside there, you see the ball in there, and measure that is about 12 millimeters. So that's about 3 millimeters, something like that. I think if we made the end piece 12 millimeters long and 332 to go in inside that nut. First job's to take the burrs off. And if you're holding a short piece in a collet, or you've got a piece that you're using that's a bit shorter, reverse it and take the burr off the other end too, because the burr, if it's a short piece of material, is going to be interrupt the way your collet runs. So sneak up on it a bit. I only took maybe 2-3 thou at a time, and lots of spring cuts so you get it reasonably parallel, and a bit of a polish with some 1200 wet and dry when you're done, and you should have a nice sliding fit. Next job's just cut him off. I'm not going to part it because with my luck and my dirty lathe today, I'm not going to find a part. So I'm just going to trim that so there's about 3 and 4 millimeters left. We're going to reverse him and counter bore it in with an angle and clean the end of him up. And with any luck, that's the last machining job. So let's have a look at all the bits over here on the bench. So that's what it looks like. It's all together. It's got a slot there for adjusting or for screwing it down. If your threads are a little bit deeper than they need to be, little dot of paint on there will make a big difference, or some silicone, something like that, some high temperature sealant, something like that. So we've got that nut and we've got this little spindle and a 3/16 ball bearing. This needs to be seated, and it's as simple as setting it up like that on a wooden bench. That's all that's going to take. Don't do it more than once. Check your ball, because if you've got one that's just a fraction soft, it'll leave a mark on it, but that hasn't. And the last thing we need is a spring. The spring thing's a bit of trial and error. These little spring kits are available in hardware stores, things like that. And to be honest, it's almost impossible to find something to do this job. In one of those little assortments. Best thing you can do is pull apart a photocopy or a fax machine or an egg beater. Something with a lot of parts in it. Find a spring, even probably a tension spring, which looks to be about right. Something like that one, or like that one. And get a couple of pairs of pliers or a vise and stretch him out like that, and then you've got a compression spring. The secret is to find one that this doesn't disappear through the end of, and that's alright. This feels pretty good actually. I'm going to leave it a bit longer, and that way we've got a bit more pressure and we can cut him off. If we haven't got enough pressure, then we need to find another spring if we're adjusting it, but we can work with that. Put that on there, and a couple of turns on there. And we've got a complete safety valve. Everything looks good, the ball's nicely seated. You can see the ball down in the hole, and it screws in the machine. So anyway, that's that for today. I've spent probably 2 hours on that. It's a pretty quick little part to make. It's a very satisfying job. It needs a fibre washer on it, something an 8mm fibre washer that just fits on there, so it'll screw down nice. You don't want to have to screw it down really tight and strip the threads or distort the threads every time you screw it down. So a fibre washer is probably best. It still needs to be set up and adjusted. Don't just use it like that. You're going to end up with an explosion. Or at the very least you're going to end up vacating the room until it cools down again, and you're going to end up with a bulge in your boiler. So that's that done. Thanks for watching. There'll be more soon. I'm working pretty hard at the moment, but I might have some free time in the next little while, and I hope to get my boiler pressure test rig and look at some other options for testing boilers at home and little boilers like this. So there will be a video about that. The next parts for this really are the burner and the engine. Not a big deal, we might get in and make the burner next. But thanks for everything and for your donations and Patreon. I really appreciate that. Sorry it's been a little while since the last video, but we're back into it now, and I'll get in and I'll make the burner and the engine parts, and we'll get this engine finished. Anyway, be kind to each other, and check out my YouTube channel, Instagram, all that sort of stuff. More soon.